right, everyone, we are back and we are going to do our second problem on our exam, bending stress. So we have this fundamental equation, and I'm actually going to start, although again, I wouldn't advise you to do this, but I'm going to start by typing it out. My fundamental equation, I'm just going to go all the way down here. So my fundamental equation is sig B equals m dot h divided by 2, and we have where I is equal to B dot, I'm going to do this, B times h cubed divided by 12 over 2 times I. So this is our expression. So it's a function of m, b, and h. So let's go ahead and let's start to break down this problem. So we have, let's see, measure the height. So number of height measurements equals 16. X height is equal to 12 times 10 to the minus 3. We're also told that the standard deviation of height is equal to 0.2 times 10 to the minus 2. We're told the width, so basically b equals 4.9 times 10 to the minus 2. And that's just a given value. I'm going to call this b nominal. So I just want to keep my expression there. B nominal. Bending moment, so Nm is equal to 42. Xm equals 15 millinewton centimeter. So if we do, let's see, and I'm going to double check this, 15 millinewton centimeter. So I need to convert this. So 15 millinewtons times, I need to get rid of, in 1 newton, there is 1,000 millinewtons. But then it's also times centimeter times, in 1 meter, there are 100 centimeters. So I'm just going to times 10 to the minus times 10 to the minus 3 times 10 to the minus 2, so probably times 10 to the minus 5. 15 times 10 to the minus 5. We can double check that. I'm just going to double check that real quickly. And then SM equals 0.01 times 10 to the minus 3 as well. That's what I'm going to do. I'm just searching for uh, 15 millinewton cm. Yeah, I'm confident in my result. So let's go ahead. SM, we've got that. The device used at the moment was dynamometer. So the uncertainty in the moment is going to be equal to 15 times 10 to the minus 6. The height was, and then there's some uncertainty in the height, which is equal, basically equals 1 times 10 to the minus 2. Height was measured with this. I'm going to go ahead and zoom, and I'm actually going to probably right now, quickly, I'm going to include that as the width as well, equals UH. So, all right, now let's go ahead. I need my t value of height is going to be equal to, we're looking at 1%, so actually, so it's 0. T of height is going to be our 0.005 of 15. So I'm going to go here. T value, I'm just moving this away. T of 005, 15. So that's going to be 2.947. So T height equals 2.947. And then T of M, our T value is going to be, I think, it's the infinity, 2.576. Good. All right. So, and I'm going to say I also need derivative of sig b with regards d sig b dh equals derivative of sig b with regards to h. And I'm going to do the same thing for height, width, and then m. Good, good. All right. So let's get at it. So we know that there's definitely some precision error in height, and that's going to be equal to t height times standard deviation, t height times standard deviation of height divided by square root of n height. And then I want to make this a fraction, so I'm going to divide all this by x height. Alrighty. And then I'm going to have the same thing, except now for m. There's going to be some precision error in m. Tm times standard deviation of m divided by square root of nm divided by, oops, I need to divide this, xm. So let's divide this here, let's divide this here. Ooh, so there's some significant, issues there. All right, so let's go ahead, and the bias error in sig b is going to be equal to square root of, I'm going to do d sig b dh divided d sig b d sig b dh times uncertainty in h divided by sig b h sig b, and then squared plus, and then we're just going to copy this 2 3. So now instead of width, is there some uncertainty? Ooh, I said uncertainty w. Ooh, I wish I wouldn't have. I keep saying everything in terms of width is b. I'm just going to change this variable because I don't like that structure. ub, um, and then m sub b, and then we should be good to go. And we're just going to slash dot. B goes to b nominal. H goes to xh, and m goes to xm. And there we go. Oof, we got some large values. What's giving us the big issues? Well, unfortunately, it's probably the centimeters. So actually, I'm going to change, or exactly the centimeters here. I'm going to change this to millimeters. And then your problem statement is now going to say millimeters. All right. So, which dominates? Bias. How can we improve it? Use micrometers. So our total uncertainty, U sig b, is going to be equal to square root of pH squared plus PM squared plus B sig b squared. Great. And if I change this to, if we measure it with a micrometer, oops, just decreases it. Hold on a second. Let me make sure. If I change this here to uncertainty times 6, yeah, we get some change in value here. Excellent. So that is pretty much it. And so again, we would just change that, and then we're fine. Now we have to kind of deal with running more measurements of height. So there's your solutions. See you next time. Thanks. Bye.